we're going to go over, we're going to try to focus on Pythagorean Theorem today. And Pythagorean Theorem is stated as this here. We're going to talk about what each of these variables stand for. Our c squared is equal to a squared plus b squared. We're also going to touch on the area of a triangle and how you kind of come to this formula, okay? So the first thing we're going to be looking at, and for our Pythagorean theorem to work, we must be using or working with a right angle triangle, okay? So for the basis of today's lessons, all of our triangles will have to be right angle triangles. If they're not, then we can't use Pythagorean theorem, okay? And we're going to talk about the sides, and specifically the hypotenuse of this triangle, okay? The hypotenuse of a right angle triangle is always opposite of the right angle, okay? So no matter where you get a right angle, let's say it's here, this would be considered the hypotenuse. Do I have any other triangles mixed up? No, I don't, okay? But no matter where this right angle is, it's always the opposite side, okay? The other two sides we can refer to as just legs of the triangle. They could be also known as the base and the height, and we'll call it in this case, we could call this the base and this the height, okay? It doesn't technically matter. What's very important is our hypotenuse, because in our formula, C stands for the hypotenuse of the triangle, okay? We're solving most of the time for the hypotenuse, sometimes not, but we have to make sure that our variable C is the hypotenuse, okay? So, I'm going to duplicate this triangle here. In other words, this side of the triangle is side C, okay? And our A and B are important but not as important. I could call either side A and either B. So I called this leg A and this leg B. I could have done the opposite and made this one B and this one A. It wouldn't have made a difference for our formula. What's most important is making sure we know what the hypotenuse of that triangle is, okay? So if we were to set up this formula, this is the idea here. Okay, we'll go back to area after. We're actually going to solve one. I kind of haven't given myself a lot of space. Let's go over here. Okay, now we'll come back to those floating triangles there. So let's say I have this side, which is equal to 9, and maybe this side is equal to 4. Okay, and we'd like to find this side of the triangle. First of all, what side of the triangle are we trying to solve for, Travis? C, that's right. Okay, so these being our legs, we're going to write our formula out. C squared is equal to A squared plus B squared. And we're going to go about replacing our A, B and C with our numbers and variable in this case. So what would be replacing our C variable? That's right. We're going to replace C with the value of X. What about A? 9. Yeah, sure. We can replace it with 9 or 4, it doesn't matter. And then that means B, by default, will be 4 or 9.
X squared.
And it will be, yeah. So when we go to replace this, the square, or the power of 2 is going to stay the same. The bases are the only thing that's changing. So this C is now our X, so we have X squared, is equal to our 9 squared, plus our B, which is 4 squared. Great. So X squared is equal to, what's 9 squared? Good. What's 4 squared? Good. We'll put them together. What do we get? Yeah, which is 97. Good. Am I done? Does that mean the distance of the hypotenuse is 97? That's right. In order to move the 2 over, we went through this. What's the opposite operation? Yeah, we use the square root. Okay. So in order to move this over, we're going to square root 97. So we'll take a calculator out. 97, the square root, is 9.85, let's say. Approximately 9.8. We rounded it up. So, the hypotenuse of this is 9.85. Does that make sense?
Yeah.
Why? In reference to these numbers, why does it make sense?
The 9 Angle A is almost the exact same length as angle X.
Okay. What did we say about the hypotenuse? It had to be what of the triangle? In terms of the length of the sides. It had to be the longest. Is this considered the longest side? Yes, that's longer than the other two legs, so that logically makes sense. So if we make an error going through this, if we ever get a hypotenuse that is less than one of the legs, we know we've made an error. That's not possible. The hypotenuse must be longer. Okay? Now, this formula, here's kind of the proof to this formula. Okay? And this is our C, this distance here. And I better highlight it in green. Here's our distance in green. This is our C. Technically, it says what? C to the power of 2, or squared. So C squared is really like the area of a square, right? This distance would also be C. So what this is telling us is this area here is equal to C squared. Okay? If this is our side A, do I have red? I think I do. Good. The distance of this side is A. And our formula states that it's A squared plus B squared. So this area of this squared is A squared. And finally, the last one, if this is our B, the area of this squared here is our B. So what this formula is stating is that the area of these two squares is equal to the area of this larger square. Okay? And that's the idea behind this. If I can break these up, maybe I can move them a little. Okay, let's move them over. We have this square here. Oh, that worked out actually pretty nice. And let's see if I can break that other square into 4 with 2 diagonals. Okay? If I break this into 2 diagonals, pull it apart. I'm going to pause for this part. Okay, so let's continue. And so we've split our triangle into 4 pieces, and we're going to try to fill in the rest. Hopefully it works here. So we'll take the example of the bottom and fit it in, and that fits perfectly there. We'll take the top one. It fits perfectly there.
Oh my god.
Our side one fits, and then our other side fits. So essentially, and I did take that triangle from the bottom. Why did he disappear? Oh yeah, I moved him. So this idea here, that this square, I didn't redraw that square very nicely, but that these two squares fit perfectly into the area of the hypotenuse square. So essentially the idea is that if you add the areas of these two squares together, they are equal to the area of the larger hypotenuse square. Okay, so that's kind of the proof with some visuals for you. Now, we finished that part. That's our Pythagorean Theorem. I want to talk about area of a triangle. And I called it A subscript T. That just means area of a triangle is equal to 1/2 times the base times the height. Yeah, base times height divided by 2. Exactly. Okay. Now, we're going to stick with what we had in our original, and I'm going to call this the base of the triangle and this the height. It technically doesn't matter because there's a rule in multiplication. It's called Associative Property. It doesn't matter what order we multiply things in. So we'll use our same values that we had before. Okay, where? I'll start talking to me. Okay, here's our 9, and this was 4. Okay, we'll call them meters in this case because we need a unit of measurement. What this states is if I take, we'll do it in light blue, this height and multiply it by this base, I'll get an area, and then I have to divide it in 2. Why do I have to divide it in 2? If I just multiply the height times the base, what shape am I finding the area of?
Square.
Exactly. So I've duplicated this triangle, and this would be the area of that total square. So in order to find it of just the triangle, we take that height and that base, and we have to divide it by 2. And if you notice, that's essentially what half of this square is. Half of this square is the triangle we're trying to find the height for. So I'll take that area formula. I'm going to do it on top here. Our area is equal to 1/2 times base, which is 9. Nope, sorry, the base was 4. Again, it doesn't matter what order we multiply in. This will become 1/2 times, what's 4 times 9? Oh, good. 36. Okay, I'm going to move these up. And then finally, what is 1/2 times 36? 18. And what is the unit of measurement? Meters squared, right? So, the area of this triangle here is 18 meters squared. What would have the area of this entire square had been? That's right. It would have been that 36. Okay. So there's a lot of similarities and relationships between squares and triangles. So I want you to keep that in mind when going through today's lesson. So the last example I do want to talk about is we're going to solve for a side other than the hypotenuse. Where's the right angle here? There. Good. Very descriptive. So here's our right angle. Which side would we consider the hypotenuse from this?
4 meters.
That's right, 4 meters. It's opposite of our right angle. So our Pythagorean Theorem helps us solve for lengths of the side of the triangle. So we have c squared is equal to a squared plus b squared. Okay. Our c
4 meters.
is our 4. What is our a? Yeah, it could be the h or it could be the 1.4. It doesn't make a difference. Okay. I'm going to call it the 1.4. And I'm going to call b our unknown, which is our h. So let's substitute our values in. 4 replaces our c. So 4 squared is equal to a is replaced by 1.4. And b is replaced with the height of the triangle. I could have still called it side b if I wanted. Any variable works fine. Now the goal is to isolate for h. So in order to isolate for h, I need to move things. And maybe it'll be easier if we square everything first. So what is 4 squared? 16. Good. What is 1.4 squared? 1.96. Good. 1.96. And then plus h squared. To isolate h, what do I need to move to the other side?
16. No.
It'll be easier if we move the 1.96. And what will it become on the other side? That's right, negative. So we'll get 16 subtract 1.96 is equal to h squared. We'll take 16 subtract 1.96. 14.04. So 14, I don't want to use that color. 14.04 is equal to h squared. Are we done? Is that the height of that triangle?
No.
How do we know it's not the height? What does this number say? And what is it in comparison to the hypotenuse? It's much bigger. Could it possibly be bigger? We'll get to it.
Yes.
It couldn't, right? The hypotenuse must be the longest side, so this doesn't make sense, so I know I'm not finished, or at least I've made a mistake. I need to square root, because that's the opposite of our power of 2. And what is it, Travis? 3.7? 3.75? Excellent. So the height of this triangle is 3.75. Does that make sense compared to the hypotenuse? Yes, because it's less than the hypotenuse, therefore it works.